हरि करना।
Now it's time to see distinguishable permutations. Distinguishable permutations are permutations in which some of the objects being permuted are distinguishable from each other. In other words, if you have a set of objects that are not identical, the number of distinguishable permutations of those objects will be greater than the total number of permutations. For example, consider the letters capital A, capital B, and capital C, and the number of times they appear. If we have two A's and one B and one C, then the total number of permutations would be 4 factorial divided by 2 factorial times 1 factorial times 1 factorial, that's equals to 12. So however, not all of these permutations are distinguishable, as the two A's are identical. To calculate the number of distinguishable permutations, so we need to divide by the number of ways A's can be arranged, which is 2 factorial. Therefore, the number of distinguishable permutations is equals to 12 divided by 2. So that's one example. So the number of distinguishable permutations of n objects, where n1 are one type, n2 are another type, and so on, will be calculated using n factorial divided by n1 factorial times n2 factorial times n3 factorial times nk factorial, where n1 plus n2 plus n3 plus n4 or and so on, nk is equals to n. So let's take one example here. Jessie wants to plant 10 plants along the sidewalk in her front yard. So she has 3 rose bushes, 4 daffodils, and 3 lilies. In how many distinguishable ways can the plants be arranged? So 10 factorial divided by, so 10 factorial, she wants 10 plants along the sidewalk. So 10 factorial divided by 3, because n1 3 factorial and n2 4 factorial and n3 3 factorial again. So 10 times again you do the respective calculation, it's a 4200 different ways to arrange the plants. So let's take another example from here. This is distinguishable permutations. So another example is when we have a set of objects that are arranged in a circle, such as beads on a necklace or seats at a table. In this case, the order of the objects matters, but the overall orientation of the circle does not. Therefore, we need to divide the total number of permutations by the number of rotations of the circle that produce the same arrangement. For example, if we have three distinguishable beats, three we have three distinguishable beats, distinguishable beats to arrange in a circle. Then the question is, the total number of permutations is equals to 3 factorial, which is 3 times 2 times 1 is equals to 6. But we need to divide by 3. We need to divide by 3 since there are 3 different ways to rotate the circle and produce the same arrangement. Therefore, the number of distinguishable permutations, so number of distinguishable permutations is equals to this permutations divided by 2. Sorry, 3. 3 factorial divided by 3, which is 6 divided by 3, which is 2.